Hi guys, today I'm going to teach you how to make a DC to DC boost converter circuit. Now I didn't share the circuit diagram in my previous video cause that was a demo circuit and it was facing some major no load losses. But this one is a very efficient 12 volts to 180 volts and up to 300 watts boost converter circuit for DC motors or LEDs. The circuit contains 6 pieces of 13009 NPN transistors, 2 pieces of 1 kilo ohm 5 watt resistors, 2 heat sinks and a ferrite core 300 watts transformer. The circuit operates at high frequency, therefore it is important that you use a ferrite core transformer instead of a laminated core type. The circuit contains 2 transistor sets and each transistor has a job of switching on and off one of the sides of the transformer. The output of the transformer is AC, which can be converted to DC with the help of a bridge rectifier. Also guys, the surface of the heat sinks should be completely level for proper heat dissipation. As you can see guys, there are 3 transistors on each heatsink and 2 of the 3 transistors are close to each other than the third one. And now that is because the 2 close transistors will be connected to each other in parallel, while the third one, which is away from those 2, will be used to drive those 2 transistors as one. This is a ferrite core transformer that I'm using for this project, and as you saw that it was using an E-type core which had more air gap, while the one that I prefer is the O-type core with minimum air gap. Remember guys, the larger the air gap, more is the current flow in the primary winding, and that high current keeps on flowing even if the circuit is on no load, and thus increasing circuit no load losses. Also guys, as you can see that there is large unwanted gap between the ferrite core and the windings, which has further increased the losses, but despite that large gap, the efficiency of the circuit is around 83%. And imagine what will happen if we can reduce this air gap. So guys, as you can see that I have connected a bridge rectifier at the output side of the transformer, which is going to convert the AC output of the transformer to DC. Also guys, I am going to connect the meter in between the battery and the circuit to measure the current under no load condition and under loaded condition. Now guys, as you can see that the meter is showing 1.20 amps, which means that the no load circuit loss is around 14 watts, which is mostly because of the air gap between the transformer winding and the ferrite core, and because there is no filter capacitor used at the output of the transformer. Remaining are the I2R losses. Guys, this is a 24 volts to 100 volts PM DC motor that I'm going to test with this circuit. Whoa, so guys, as you can see that the starting torque is very high and the final attained speed is also very high, and the meter indicated around 7 amps at the start, and after it attained constant speed the amps reduced to around 3.10, which means it was drawing around 36 watts from the battery. Yeah, the result is really good.
Okay, so guys, this is a very expensive 300 volts DC motor, a magnetic DC motor, which I'm going to test with this circuit. Okay, so guys, the motor has been connected to this bridge rectifier. Let's connect the power supply. So guys, as you can see, as soon as I turn on the supply, it starts vibrating and this meter shows that it is drawing around 3.5 amps. Now that is because of the improper pulses that are coming out from this transformer. So to improve the pulses, I am going to use these two parallel connected capacitors, and both of them are identical. I have connected them in parallel to increase their capacitive value. So yeah, let's connect them to this transformer's output. Okay, so guys, as you can see that the capacitor has been connected. Now let's test it again. Yeah. Yeah, it took some time, but it stabilized, and also now it is drawing a very less amount of current, which is only 1.26 amps, and the torque is also very high. It is just unstoppable, and when I put some load, obviously the current here increases. Let's see if I can stop it. Yeah, and because of this gear, it is pushing my hand backwards. And no more vibration. And one more thing guys that I just found out. Now when I remove this terminal from this motor, so as you can see that this wire has been disconnected from the motor. Now when we measure this no load current drawn by this circuit, it is lesser than it was initially. You can see it is almost 1 amps, and without those two capacitors it was around 1.20 amps. So these two capacitors have obviously improved the efficiency of the circuit, and also there is a lot of gapping between this core and the winding, which is further creating a loss because I didn't get an exact match of the ferrite core that I have used. So if you have a proper one and if you are going to make a circuit similar to this one, I would recommend that the gap between the windings and the core has to be as low as possible. Closer view. Yeah, okay, so guys, that would be all about today's video. Thank you so much for watching it. Please hit like and don't forget to share and subscribe.